Started going at this in earnest with the first efforts on the data policy manual, and this process has been sort of up and down, and we think we've settled on a good place to go forward with actual action without sort of a lot of gray area, and so we're going to talk to you a little bit about that today. So when I say that I'm going to list some of the challenges, I'm going to talk about our current solutions to these. This doesn't mean that these are the solutions we use going forward forever, but in a sense, it means that we've kind of taken a first step, and that we have a sense of what we think is reasonable at this point. First off, I should say something about the Hpp Platform Ecosystem. So there's 6 sub-projects in HPP that are focused on building platforms, and these are hosted at partner institutions around Europe. So it's a distributed infrastructure in the terminology of the European Commission, which means that you have services spread out at different locations around Europe, using the expertise of those sites and delivering strategic tools for neuroscience. So we have a Neuro-Informatics sub-project, which is primarily located at 3 sites, University of Oslo, Eureka Laboratory in Jülich in Germany, and EPFL in Switzerland. Brain simulation, which is the platform building itself, although not all the activities, is happening primarily at EPFL as well. Medical informatics is happening at CHUV and in an institution in Greece. I don't remember the exact name, unfortunately. If you ask me after, I can tell you. If there's anybody that, No, it's in Greece. I think it's at the University of Athens, I think. I have to double check that one. Is that, okay, well, I'll check that one and get back to you. High performance analytics and computing. I'll say a little bit more about these guys because this is actually really key to being able to make the Neuro-Informatics platform available. They've been a huge collaborator with us over the last 2 years, and we really wouldn't have been able to get as far as we have without them. There's a neuromorphic computing group, which has 2 different types of neuromorphic processors and is looking both at robotics applications, machine learning applications. Sorry, not both, at many different applications, but and also, let's say, looking at new ways of learning from fundamentally informed by theory and theoretical neuroscience. And then finally, you have Neurorobotics, which is looking to build better robots based on biologically inspired models. So I'm going to talk mostly about SP5 today, which is the Neuro-Informatics platform, and we're focused. We see an infrastructure needs to have a user, and we're user-centric in a lot of ways. And these numbers that I have up here for the estimated user bases are kind of guesses. If you have any slightly better information, I'd love to talk to you, because it's a little tough to characterize these things based on, it's kind of, you take a couple data points and you fudge some numbers, and Greg's shaking his head, nodding his head up and down. He's like, yeah, it's okay. Okay, if Greg's nodding, I'm okay. But in theory, these are some of the targets, the low-hanging fruit that we can target with the Neuro-Informatics platform strategy that we have today. So one part is, let's say, a next-generation interactive neuroanatomy textbook, something like Google Earth for the brain, but with some additional intelligence built in and analysis capabilities. Data publications we think are a big deal. Obviously, this is something that this group cares a lot about. I'll talk a lot more about this in this presentation. And the neuroimaging community, we're not focused so much on this group at this point in terms of our current push. This will be a focus. This will be a much bigger focus in the next phase, which is starting in about a week, and goes for another 2 years after that. So the goals of the Neuro-Informatics platform are these in terms of overarching high-level goals. This is taken from a slide from Jan, who's the SP5 leader. So I feel pretty comfortable in stating these as our overarching goals. Establish infrastructure and tools for integration of heterogeneous neuroscience data. Make data discoverable and available for reuse and analysis. The one thing I would say about this is that our focus currently is on animal data or human data that has been cleared for wide reuse. So in the Neuro-Informatics platform, we've kind of sidestepped a little bit some of the more touchy subjects, touchy ethical issues around human data. The other point is that this talk doesn't talk at all about the medical informatics platform, which is kind of a separate beast. And what that one is really focused on is unlocking large-scale access to clinical data for machine learning applications, mining disease signatures, personalized medicine. I can talk more about this, but I don't have time in the current talk. So So Neuroinformatics. So we start on the left-hand side there with models and experimental data. So we take this and we upload it to an HPC center. We spent a bit of time getting this right. It's not quite as easy as you think to move terabytes of data. So getting that into the data centers took a little while to figure out. And then the step after that is we go through something called Tier 1 curation, which is about making data fair. I'll talk a little bit more about that later. Really, at this point, it's enabled for faceted search and download. So you have basic reusability, accessibility, findability characteristics at this point. And it's available for analysis with the analysis tools that we provide in SP5 and with others. The next step beyond that is Atlas integration, where we have teams with specialized tools that are actually taking data that comes in and registering it to an Atlas. So this is typically a manual process because you don't have, you maybe just have a collection of slices from a single brain. So it's not actually a full brain at this point. So it's typically a manual process. There's some work on making this semi-autonomous for some human applications, but in practice, that's what we have for Tier 2 curation. And this makes it available for interactive Atlas viewers. And then finally, we have deep reuse integration, which is more of a proof of concept in the current phase. But here we're looking at pulling out detailed experimental metadata and making this available through the database search interface. This is early days in this one, but they've made some interesting progress in terms of modeling the experimental, or modeling the domains that you would use to find the data. And the outcome of this is that this data can be used either in prediction, modeling, and simulation. So on the simulation side, it can be used for validating simulations. It can be used for actually as an input to the simulation construction process. Depending on what modeling techniques you're using, your use of this data will be different. The other one is that we expect that there's actually going to be wider use by the community, and this fully curated data is quite important. Before I get into the definitions of, or sort of this FAIR concept, I wanted to talk a little bit about why data policy matters to the distributed infrastructure. So one thing about the GDPR is that if you've ever read parts of it, it's not always clear. The definitions are a little strange. They don't really match directly to what you're using in a research field, so this makes things a little bit challenging. HPP has spent a lot of time on this. This has been a big piece. Cheers, kind of laughing to herself here. So it took us quite a while to kind of digest this thing and turn it into something that we could actually use. So I mean, really, when we're saying that, we're actually saying all the people that were involved in this data policy manual spent a lot of time digesting these documents and trying to understand them from their own angle. The reason why this is important is because obviously the penalties are pretty substantial. So if I talk only about EPFL's budget, you have a $1 billion annual budget of 1 billion CHF, which is roughly a billion US dollars, and that translates into a $40 million maximum fine for EPFL if I do something wrong in my data policies. So that's pretty significant. This is why it's important to take this stuff seriously. I probably wouldn't have a job if I screwed up to this extent after. But on the other side of this, scientists typically have difficulty reusing data for some of the reasons that Karen talked about, but I mean, ethical compliance and provenance is not clear. This doesn't stop some scientists, scarily enough. So we've actually sort of talked to scientists that are using data, and we're like, oh, where did you get that data from? We'd like to include it in the Neuro-Informatics platform. I think it came from over here. And you go and talk to that person, and they're like, well, it came from over here. And so you actually, as you walk back through the chain, you eventually find the answer, but the person who was using the data at the beginning wasn't aware. So they didn't have that answer when they started using it. So this is kind of interesting. Licensing and conditions for use is not clear. Again, this doesn't stop certain people, but it should. And it's, I think, we're kind of looking, I'll talk a little bit about this, but we're looking at a bit of a chicken and egg problem here because people aren't used to reuse, they aren't typically sort of sensitized to the issues that arise. But as they become sensitized to the issues, it'll again be this tension. It'll keep them from reusing data that they don't trust. But this is it's going to be a growing consciousness, I think. Formats aren't well documented. So you have something that's in Excel format. That doesn't really mean a lot. You can read it in Excel, but that doesn't actually tell you how to interpret the data. Spatial metadata isn't accurate or is completely missing. Experimental data metadata isn't accurate or is completely missing. One thing that's actually a barrier somewhat to reuse, which doesn't really get spoken of very often, is that almost all, well, I can think of many, many examples in the HPP where when data goes to reuse, the person who's reusing it for some unintended purpose finds an error in the data. So what happens then? So that's kind of interesting. I just want, who here is familiar with the FAIR term? Actually, rather, who here is not familiar with the FAIR term? Okay, so this was, I'll go through this slide. So this was originated by, at least to my knowledge, under Force 11, which they coined this acronym, which is findable, accessible, interoperable, and reusable. This is widely used in the data management environment in European research. And these are the conditions that they would offer you as requirements for these definitions. And I think, I mean, haven't actually reviewed these since we started the Neuro-Informatics platform effort, but we do pretty good on these actually, with our current plan. The only thing that I think was a little bit questionable was A2. Those guarantees aren't really in place because we don't have service level agreements yet, which I'll talk more about later. I think I1 is maybe questionable. I2 is pretty good. I mean, in practice, I think it's going to be up to the community to really test these things to make sure that they're valid. It's kind of like the data. Your data is only really good if it actually gets used by many people. So I think this will be something that'll be interesting to find out later on. But I mean, here we're really talking about things that are not. These are not. What I'm talking about here in terms of challenges, they're actually the biggest challenges to this environment are actually not technical problems. So being a platform builder, being a software engineer, I usually think first about the technical problems, but these are actually not the biggest issues. Mostly they're social problems, as Karen was mentioning. I really strongly believe in this as well. And so, I mean, this value around data publication is really not clearly understood. And FAIR does take a significant effort on the part of the scientists. One of the things that we're doing in HPP is trying to build a support structure both on software and services side and on the curation team side, which we'll see a little bit more about later, to make this process, to streamline this process and make it easier for researchers, because there is a lot of things that you're not trained to think about. You don't have the tools. We try to provide some of those. And by doing this, we hope that we can provide a little nugget of data that will encourage people to come back and start to understand why they would share reuse data, to understand sort of the value of doing it for themselves, and to provide them with a support system that would actually help them to do the same. So we're building really on best practices in the community. There's actually quite a lot of people out there that are already doing this. So we've tried to steal all the best ideas from around the community. Two good examples of large-scale data sharing sites are Zenodo and Figshare. So we've taken some of their approaches. We believe that metadata should be widely shared. So if you release your data set, you may not necessarily have to share the data because it might still be under embargo, but the metadata would be visible to everyone. So this is something that the only exception here is that we have, as part of the curation process, you're required to put in ethics database IDs so that we can link back to the original ethics approval, but we don't show this database ID to anyone. We just show the ethics authority. So we know that it's been actually checked by this group, but we don't actually show the database IDs publicly. We provide DOIs on the data sets. We have a concept of a data custodian, which is normally a PI. We used to call them data owners, but we switched as part of the work of the data policy manual group, because we realized, or someone very rightly brought up during one of our meetings, that we were using the concept of a data owner, and a data owner actually doesn't apply under the GDPR for human data, because the data owner is the data subject in this case. So we actually switched this in the curation pipeline a couple of weeks ago, because it came up over the course of our interactions with the data governance working group. So the other thing that we try to, we do make a lot of effort to guarantee is that we have minimum access to data sets during the curation process. So if you're a researcher and you're coming in and you're working with your data sets or you're using them for your own research and you want it to be under embargo, you can have pretty strong guarantees that no one else is going to access it prior to releasing it under embargo. So we have this well locked down process whereby none of this data can leak out. And we've made best efforts to be GDPR compliant, although this is, I think we still have some work to do here. In terms of role mapping, so in this platform landscape, it's a little bit unclear who is who and what they're doing. And these are my best reads right now for what these mappings are. So platform operators / institutions typically are ones that are operating the platforms are GDPR data processors. In this case, the data curators are acting as data processors as well. Data custodians are most regularly data controllers because they're the ones who are actually sort of moving the data around and making decisions about where they go. This is up for discussion, by the way, because I know there are other people that have opinions about this. I put it up here partly because I'd like to actually have these discussion about this. The other thing that we've done inside the Hpp, which is sort of meant to try and improve on our compliance. So normally, a legal entity is supposed to have a data protection officer, and Hpp itself is not a legal entity currently, but we're kind of taking this preemptive step to install a data protection officer to actually do this work to make sure that when we get to that point, we're already prepared. And this is actually, again, thanks to SP12, the ethics sub-project, they made the push to actually have this installed, and now we have, we're sort of getting ready, in a sense, for this effort. And these are the sorts of things that when we go for our infrastructure pitches that we know will be very well prepared because we'll have these things already in place. So going back to the curation goals, I'll skip this one because I want to try and allow time for discussion. So tier 1 curation is hard work. So this is Jan's team working with Christer Anderson here. We have 107 studies in the pipeline when the screenshot was taken. This is the Curation Dashboard. So each of these represents a study, some set of animals with a battery of experimental protocols run on them. And this process, this is a snapshot from roughly end of January, I believe. So there's more data sets in the pipeline now. And this is sort of tracking the ongoing curation efforts as we go through. What this looks like in a sense, this snapshot that you see here, I'll have to go back. This snapshot that you see here is actually this part, if I can, oops. I have a laser pointer here somewhere? No. Okay, so this is the tier 1, so that workflow that I showed you before is this little piece right here. Actually, sorry, it's these two pieces right here. Later versions of the screenshot include a knowledge graph portion. And this is kind of the planning all the way to tier 1 data production in data lifecycle in HPP. So we have our initial planning, which happens usually during the proposal phase, but we revisit this periodically throughout the production phase. We do data upload to the HPC centers. We do our data curation. We import it into the knowledge graph, which is a metadata database that we've built in this phase. And at this point, it's now searchable via APIs or via a nice web interface. And at this point, it may or may not be released. The data may not be accessible because it might still be under embargo. So we will still show metadata for data that's under embargo because we still think that in some cases, you might want to contact the author and get an early access to it. And we think this is reasonable for some cases. And yeah, the two orange boxes are the ones that are actually publicly visible. So this is, so we were really under quite a lot of time pressure. We had quite a lot of data sets to address in this phase. So a big part of our workflow uses that time-proven IT tool, Excel, to manage data on what we have. We have a sort of form that we use for managing our metadata. We're not proud of this, but it works very well. And you can see here that we've sort of collected data about so if I go up to this map, you can see. So this is information from our planning database. This is the linkage into our planning database. This is information about the ethics approval, some protocol tags, data set ID from the institution. So if they want to come back to their own internal database, they can use that. licenses. So we have a battery of licenses that they can select. Data owner, which has actually been, so this is an old screenshot as well. Updated versions have this as data contributor. And then any contributors, and this is the information we need to register a DOI for this data set. We also have specimens and samples, but mostly this data is just intended to provide you with information about to allow you to find data sets that are potentially interesting. And really we're just talking about tier 1 metadata, just enough to make it fair. It's not shown here, but we also typically have format information as well. The other thing that we try to capture, again, this is stolen from practice that we've seen in the wild. I think this is from, I noticed this one a couple of years ago when I was looking at the Neurodata Without Borders website, which is a pretty nicely done, based just on a simple wiki, but they actually embedded the method sections for the studies that they've done. And this actually provided a huge amount of information in terms of reuse, so we decided to do the same. And then any links to related publications in the event that this provides you with, as a person who's coming in to reuse the data, this provides you with potentially additional information about what the data really is. To do this, we have a few products. I'll skip through these quickly. This is our curation workflow support system called Data Workbench. This manages the release and curation of the data sets. Sorry, just for fun. Time honored tool, labs everywhere, Excel. Once it makes its way into the knowledge graph database, we have an internal analytics system for doing consistency checks on that database. It's a fairly complex system, so we do have to do some consistency checks. It's a hybrid semantic graph database. I'm happy to talk to you more about that. I won't bore the social scientists with this kind of stuff. Final stage is our public search interface. Well, actually, it's not public yet. It'll be released on March 31st, 2018. And this is where you can find the data that's in the HPP. Again, I'll probably skip this one. But behind the scenes, you have quite a rich ecosystem of services. This requires a fair bit of expertise to build. One challenge we find in the research community is that funding these types of developments is a little bit tricky. We're lucky in the HPP that we can do this, but it's not something that is readily accessible to research groups. In the tier 2 space, we have special tools as well. So we have landmark registration tools for 3D data, 2D image data validation, and we're in the process of actually defining how this will end up in the knowledge graph so that when you'll be able to search both from the, well, it's currently inaccessible, but when it is released on March 31st, you'll be able to search for the data sets, but you'll also be able to search for, the phase that we're going to take on after that is going to be to actually enable search from the Atlas interfaces, which are these ones. So you can see these ones here. So this is based on a tool that was developed at Genelia Farms and Google. It's called Neuroglancer, but we've extended it. We've wrapped it in a component interface to allow you to use it in different types of applications. And this data set, we've published 4 HPP data sets through this system at this point. But there's an expectation that you can embed additional tools in here, that you can use it as its own search interface and for some analytics as well. One of the places we expect to use it is actually, there's a tool that's widely used in image processing in neuroimaging called Elastic. And we're going to be integrating this as a Neuro-Informatics platform service in the next phase. It's not currently available. We're doing proof of concept work to make sure that it's feasible, but allowing you to do sort of analysis and then to actually view the results after the analysis has been completed. This is more of a proof of concept activity, but we have a neural activity resource which is meant to actually do a more detailed breakdown of the metadata for activity studies. So calcium imaging, electrophysiology, etc. This is based in part on the experience of Andrew Davison, who is responsible for something called the NEO framework. So you have a fairly rich data model describing different experimental protocols and how to break them up into pieces. And we expect that this will make some of the neural activity data a little bit easier to digest and reuse. So you can kind of see as we go through this, we have a tiered process. First is to make it available, accessible, findable. The next step is to make it reusable from a spatial standpoint, and the next step is to make it reusable from a more protocol standpoint. We have some tools that we use for analysis of activity data. I won't say too much about that. So downstream from this, we also provide in our Informatics platform something called the Hpp Laboratory, which is a hosted Jupyter notebook environment that comes with batteries included. We provide neuroscientific analysis libraries here. And you have sort of a user-defined workspace. And you can go in there, if you're sort of somebody who uses Python or is a Jupyter notebook person, you can go in, you can request an account, and you can start using Jupyter notebooks there if you want. On top of this, the brain simulation platform provides a number of use cases. When you want to actually do one of the things that you do in the brain simulation platform, it clones a collab for you and provides you with all the documentation and tools that you need to actually execute one of these fairly complex modeling pipelines. We also have the Neuro-Robotics platform. I won't say too much about that one because I think I'm running short on time. We also have a software catalog, which includes software from inside and outside of the project. One thing I wanted to talk about a little bit more about. So you'll see in some of the coming slides we have a group called Phoenix, which is it's technically separate from HPP. It's a funded infrastructure effort from the European Commission that is an alliance of supercomputing centers, sort of a subset of the PRACE network. And they're really focused on providing a federated data infrastructure for HPP and for other groups. But I don't think I would be inaccurate if I said that the genesis of this Phoenix project is largely based on the collaborations that we had with them over the last 2 years. In the sense that we helped inform what they were looking for in terms of the requirements when they went to do the proposal. So it's a good example of co-design in its normal sense. I probably won't talk too much about this one. I'll skip this. Okay, so in terms of first steps towards a trustworthy data repository, one of the things that we are going to be working on in the next phase is service level agreements, so that normally HPC centers are quite good at providing secure, robust environments that have good reliability guarantees, and they're generally quite well managed. However, we would still like to have service level agreements so that we can be confident that they have the right legal framework in place to make sure that they protect the data in the right way, and that they manage their security in the right way. We believe that the public ethics metadata provides confidence to users that the data can be safely reused, and we are already providing clear licensing conditions, so making it easier to reuse data in the platform. And then in terms of future work in neuroinformatics, but this is kind of a general effort in HPP, really working to try and improve the incentives for scientists to publish their work, publish their data, more importantly. So working towards adoption of recognized data impact factors. I mean, I've looked at a few of these things recently. I haven't seen anything too compelling yet, or anything that seems to be widely adopted, but this stuff is out there. It's just, it doesn't seem to be widely recognized. Improving curation tools just to make sure that we can actually, so that when we are going to be going out and talking to data producers outside of HPP, and we are going to be pushing to get their data into the system. We have a few good collaborations with this already spun up from outside of HPP, but this is going to need to be supported by better tooling, so obviously we want to try and make this process more efficient. Possibly some integration into some lab information management systems, and obviously working with data custodians inside and outside of HPP to curate their data. Points for discussion. So that's kind of the end of my talk.